So since all of you are new, so what I'll do in this class, earlier what I used to do is I used to place the video, the pre-recorded video which I have recorded earlier, and then in that video I've explained the question well. After explaining the question, I'll tell you the related concept, and then I'll move towards the final solution of the problem. So today I'll try to follow the same for the first question. For the second question, I haven't recorded the video yet, so I'll explain it to you directly. Yeah. So the first question which I'll be covering is related to the temperature stresses. This should be an interactive class, and I want you to sit with your pen and paper, because after solving the gate question, you should quickly write down the formula which I'll be deriving, or the formula I'll be using in that problem, because the same formula, after that problem is over, I'll give you a practice problem which I'll ask you to solve. If you can try that problem, otherwise I'll solve it myself. So it's better, so because in structures you can't just sit and listen to the problem and the solution. Until and unless you'll do it yourself, it doesn't sink in your mind. Okay, so I want you to sit with a pen and paper, and at least while I'm discussing the video, or while I'm solving the gate problem, you should write down the formula. So after that question is over, I've formulated a similar kind of problem using the same in which the same formula is used, so that you can practice yourself then. Okay, and preferably you should have a calculator in your laptops, or in your because a normal calculator you will not be using in your gate problem, so it's better you practice with the gate scientific calculator only. So maybe some app or some software should be there, like if you'll search in the Google, then you'll find us maybe some scientific calculator, so that during the exam you'll have the practice to use the laptops or the desktops. I hope it is fine. So please sit here with your pen, paper, and preferably a calculator in your laptops. So I'll be sharing my screen now. Please give me a minute. I hope my screen is visible now. Is it? Any one of you can respond?
Yes, ma'am.
Okay, thank you so much. And after, while I'm discussing, you should please at least note down the formula which I'll be using, because in the next, after this, I'll give you a practice problem in which you'll solve it yourself. Okay. And I want this class to be interactive, so if you have some doubts, you can stop me anytime, or if you are hesitant, you can write in the chat box, I'll answer. Okay, now I'll be playing this video. Please listen to it carefully. I have explained the question well, and even if you don't understand it this time, I'll explain it again. Okay, and then I'll give you the practice problem. Hello everyone. So today I'll be discussing question number 50, set 2, Gate Civil Engineering 2022. Consider two linearly elastic rods HI and IJ, each of length B, as shown in the figure. The rods are collinear and confined between two fixed supports H and J. Both the rods are initially stress-free. The coefficient of thermal expansion is alpha for both the rods. The temperature of the rod IJ is increased by delta T, whereas the temperature of the rod HI remains unchanged. An external horizontal force P is now applied at the node I. It is given that alpha is 10 to the power minus 6 per degree Celsius, delta T is 50 degrees Celsius, B is 2 meter, and AE is 10 to the power 6 Newton. The axial rigidities of the rods IJ and HI are AE and 2AE respectively. To make the axial force in the rod HI equal to 0, we need to find the value of external force P. It is a fill in the blanks type of question having 2 marks and no negative marking. For a detailed lecture on this, you can refer to Analysis of Strain 4th lecture series on Strength of Materials by Professor S.K. Bhattacharya, Department of Civil Engineering, IIT Kharagpur. For those who were also present in the last class, I have covered a part of this question earlier also. But since I haven't covered the practice problem like correctly or properly, then so I'm like explaining it again. Okay. Let us discuss the concept for this problem. So whenever there is a change in the temperature and the material is constrained, then the stresses are developed in the material, and these stresses are known as temperature stresses. No stresses are developed in an unconstrained material. Let us suppose there is a bar of length L and we increase the temperature of this bar by delta T. So what will happen? Since this bar is unconstrained, so there will be an increase in the length of the bar due to increase in the temperature. So what will be the value of delta? Let us call it delta 1 will be equal to length times alpha delta T. Okay. So remember, since this is an unconstrained material, so no stresses will develop in case A. Let us see another case in which the same bar is having supports at both the ends. So in this case, and the temperature of the bar is increased by same delta T. So in this case, the stress will develop in the bar. We'll call it sigma. So the value of stress will be such that the deformation of stress due to this stress sigma will balance the deformation due to temperature. So what is the deformation due to this sigma? The deformation due to this stress sigma, let us call it as delta 2, will be sigma L by E. So in order to find the value of stress which is developed, we will equate delta 1 and delta 2. So from this, value of sigma will be E alpha delta T. Let us see one more case. So in case the support yields by A amount. So in this case, the stresses will be developed such that the deformation due to the stress will only have to balance delta 1 minus A amount, not the entire delta 1 amount. So we will equate the delta 1 minus A amount to the deformation due to stress in order to find the value of sigma, that is the stress. So what is delta 1? That is a deformation due to temperature. It is L alpha delta T minus the support yield equal to the deformation due to stress, that is sigma L by E. So from this we can easily find out the value of sigma, which is L alpha delta T minus A times E by L. Keeping these concepts in mind, let us find a solution for our problem. So in our problem, it is given that the temperature of bar Ij is increased by delta T. So when the temperature is increased, it will undergo some deformation. At the same time, it is given that the external load P is applied such that the force in the bar Hi is 0. This also implies that deformation of the bar Hi is 0. This can only be possible if the deformation due to the external load P balances the deformation in the bar Ij due to increase in temperature. So let us equate these two deformation. What will be delta P? It will be P, the length of bar B by AE. What will be the deformation due to the increase in temperature delta T? It will be length of the bar alpha delta T. So the value of P will be, B will be cancelled, be A E alpha delta T. The value of AE is 10 to the power 6, alpha is given 10 to the power minus 6, and change in temperature is 50 degrees Celsius. So the value of P will be in Newton and it will be 50 Newton. So this is our final answer. The value of applied force will be 50 Newton. So now I'll explain a little bit more, and after this we'll solve the practice problem. Okay. I hope my screen is visible. Okay. So what was given in this question, we'll quickly revise. Okay. So in this question is basically related to temperature stresses and also the stresses or the deformation due to the axial load. In earlier years, what happens is the gate people used to give either the temperature stress question or the deformation due to axial load or something, but now they have like modified the things a little bit, and they have incorporated all the things in a single question as the competitiveness of gate is increasing. So in this question you can see that there is a temperature stress also, and there is a load P also. So you can't just now remember the formula of temperature stress or the deformation due to the axial load and simply put the formula and get the answer. Now you have to think a little bit more. Okay. So in this question, both the things are incorporated in a single question. The question was, there is a bar is a there's a bar in which the temperature is increased. Okay, the temperature of bar, not the entire bar, just the temperature of this ij part is increased at the same time. So what happens if the temperature of a bar is increased? Whenever the temperature of something or some element is increased, there is an increase in the length of that part. Okay, so when the temperature of bar ij is increased, it is expected that it will elongate a bit, right? I hope everyone agrees. Okay, whenever the temperature of this bar ij will increase, it will elongate a bit. But since there is another bar attached to it, hi, so when ij will increase in length, then hi will also be affected, right? Maybe it will decrease in length a little bit, because this length up to ij should be same, because these are fixed supports. So if ij is elongated, there should be some effect in hi. Okay, I hope everyone agrees. Okay, but it is given that at the same time this load P is applied such that the force in the rod HI is 0. See how they are like twisting the problems. Okay? So they are giving that at the same time this P is applied such that the force in HI is 0. Okay. Since force in HI is 0, what does it mean? Since there is no force in HI, it also implies that deformation of HI is 0. So in a way, they have given that the force P should be applied such that deformation in HI is 0. What does it mean by deformation in HI is 0? Since HI is not deforming, this means that this ij rod is also not deforming, because if ij would have like deformed, hi is attached to it and hi should also be deformed. Okay, so in a way they are implying that the stress due to the deformation due to the increase in the temperature stress should be balanced by the deformation due to the axial load P. So by giving this term, like the force in hi should be 0, they are implying that the deformation due to the temperature stress in the rod ij is balanced by the deformation due to the application of the axial load P. See how they are twisting the problem now. So we have to simply equate the deformation due to this load P with the deformation due to increase in the temperature. So we all know that when a bar is subjected to an axial load P, so the increase in length, the deformation is given by PL by AE. Everybody knows that, right? So this deformation PL by AE should be equated to the deformation due to the temperature stresses. So what is the deformation due to temperature stresses? We have seen that it is the deformation due to temperature stress is equal to L alpha delta T, where L is the length of the bar, alpha is the coefficient of thermal expansion, and delta T is increase in temperature. So finally, just this thing we have to think. We can't now just simply put the formula and get the answer in gate. We have to think a little bit. Okay, so we have equated now PL by AE. What is the length of IJ? It's B. So PB by AE is equated to L alpha delta T, where L is B here. So B alpha delta T. By equating these two, we simply get our answer P equal to 50 Newton. Okay, also you should keep in mind the units in which you have to give the answer. You have to give the answer, it is clearly written that in Newton. If by chance you will give it in kilonewton, your entire answer will be wrong, even if you have solved it correctly. So you should keep the units also in mind. Okay, so you should now note down these formulas of the stress is E alpha delta T and stress in case of support yield. In this case, there was no support yield in this question, but maybe next year or maybe next to next year, you'll get some question in which there will be a problem with support yield also. So in a practice problem, I've included a problem related to support yield. Let's see. Okay, so this is the practice question I've given for you. So in this question, it is given that a rail is laid. Rail, I hope everybody knows the railway track wali rail. That rail is there, which is having a length of 12 meter. Okay. At the time of laying the rail, the temperature was 20 degrees Celsius. Okay. It is expected that the temperature is increased can be increased to about 50 degrees, like in a hotter climate it happens now. In the cold during the winters the temperature is 20 degrees Celsius, and during the summers suppose it is increased by 50 degrees Celsius. So the question is, estimate the minimum gap between the two rails to be left. Okay, so what happens is, when you are laying the rail, suppose there are two rails. Okay, if there is no gap between these two rails, okay, if there is no gap between these two rails, and if there is temperature increase, suppose there are two rails and there is no gap between them, and there is temperature increase, so what happens, there will be some stresses will be generated in these two rails. Okay, so whenever the rails are laid, there is some gap left between the two rails. Okay, so the question is asking, estimate the minimum gap between the two rails to be left so that there is no stress in the rails. So this is the question. Please try it. I'll give you maybe 2 minutes, then I'll explain. It's a very simple question based on the deformation due to temperature stresses only. What should be the minimum gap between the two rails so that no stress will generate in the rails? The length of rail is 12 meter. E is given 200 GPa. I think it is correct. But is it the units are correct? Please check. E is 200 GPa, or you can write it as 200 into 10 to the power 3. Yeah, Newton. Yeah, MPa maybe you can say, or Newton per mm square, right? 200 into 10 to the power 3 Newton per mm square. E. Alpha is given 12 into 10 to the power minus 6. You can write in the comments if you have solved. I think Gokul is right. Let's see. It's a very simple question. Okay. At least you should try. Whether you give me answer or not, it doesn't matter. Let's see. Let's see. There are two parts of this question. Maybe in the next part we need H or E, or maybe it is just given to confuse us. Okay. Just at least try. Okay. There's no hurry. Maybe you will not give the answer to me, but if it's for your own practice. Maybe in the next year you'll get such question in gate. We don't know. Great. So I hope you are trying. That's great. Okay. So for no stress, there should be like this delta should not be there, at least this delta gap should be there between the two rails, so that there is no stress. If the gap between the two rails is less than this delta, that is an in length, increase in length due to temperature stress, then definitely there will be stresses in the rails. So at least this delta gap should be given in between two rails. Okay, so how this delta, you know the formula, that the increase in length due to temperature stresses, you know, the increase in the delta is given by L alpha delta T, that this formula I have explained earlier. Then just have to put the values, everything if you keep in mm and newton it would be better. Okay, so you you set your favorite units beforehand only, so you know that you solve everything in newton and mm, so keep it there. So keep it like same for every question, so that you won't get confused with the units, because when you are solving it very quickly, everything you can get it quickly, but you might get like make mistakes in the units. Okay, so delta is given by L alpha delta T. L, length of the bar, my favorite units are newton and mm, so I always solve using that. Length of the bar is given 12 meter, so I've converted it to mm. So 12 into 10 to the power 3. Alpha is given 12 into 10 to the power minus 6, and increase in temperature, which is 50 minus 20, that is 30 degree. So delta is coming out to be 4.32 mm. I hope it is clear. If anyone is having any doubts. Okay. So I always say that first you work on your accuracy. There's no need to speed up the things earlier. Then after you develop some level of accuracy, then you should work on your speed. Okay. So first you try to solve the problem correctly. Then after solving a lot of problems, you'll get the speed as well. So the second part of the question is, what is the gap? So suppose we did not provide. So this delta mm gap is required so that no stresses are generated. Suppose we could not provide that much gap. Okay, so we have provided some lesser gap. Yeah, so we provided some lesser gap. So question is, what is the gap left between the rails if stress developed is 45 MPa? Okay, obviously the stress will develop if you, okay, suppose I'll ask you, if delta is given as is coming out to be 4.32 mm, and I provided a delta of around 6 mm, so whether the stress will generate or not, you can give me answer in the comments, or maybe you can unmute yourself also. If for no stress, yeah, that is right, because for no stress minimum gap is 4.32 mm. If we provide more than this, then there will be no problem, but the problem will arise when the delta is we'll provide is less than. So question in the second part, it is given that stress is developing, that is 45 MPa stress is there. So definitely the we have would have provided the a gap lesser than 4.32 mm. So they are asking what is that gap. Okay, what is that gap such that the stress develop is 45 MPa? Okay, okay, I'll explain it. I think it's correct. So I'll give you maybe 1 minute to quickly. So I'll give you a hint that this is based on yielding of support. Yielding of support formula, which I have explained earlier. This is based on that. Okay, suppose I'll explain it again. Suppose there are two rails. There is no gap in between them. Then I've explained what will be the value of stress that will generate. The stress will generate E alpha delta T. When there are two rails and there is no gap between them, the stress value of stress will be E alpha delta T. But now we have kept some gap. Okay, so when there is no gap, E alpha delta T is the value of stress. When there is some gap, so what happens? This rail will expand up till this gap. Until up till this gap, there will be no stress. But after this, when it will try to exceed this gap also, then only there will be stress. So this is a case of yielding of supports. Okay, so same like yielding of support formula we have to use. Okay, so I hope after using the yielding of support formula anyone could solve it. Like yielding of support formula, I'm giving you hint also. Like it is the formula is I'm giving it to you: L alpha delta t minus a. Okay, minus a is the gap up till which no stress will generate. L alpha delta t minus a e by l. So simply this formula we have to use to find the value of gap a, because till the time the rail will there will be a gap, no stress will generate, so it is a kind of yielding of supports problem. Okay, so I'll give you an answer now. This is a case of support yield. We have to simply use the formula L alpha delta t minus a e by l. We have to put the values in it and we can get the answer now. Any confusion or you want me to explain it again? I'll explain. You can ask me as many questions as you want. I'm there to help you only. Okay, so don't get disheartened if you couldn't solve in a one go. Maybe after 1 month or so I'll be having a competition among us you to get the answer first. Okay, is it okay? Should I move towards the next question?
Hello, ma'am.
Uh-huh.
Repeat the question.
Repeat the entire question. Okay.
Yes. Yes.
The practice question or the main question? Uh,
Not main question.
this practice
Recently, you discussed.
this practice question, right?
Yes, yes, ma'am. No, second part. Second part, ma'am.
Second part. Okay, no problem. So in the first part is clear, right? So there are rails. Okay, there are two rails which are laid during the winter season. Okay, now the season is changed to summer season and the temperature is increased by 50 degrees Celsius. So firstly, the first part was estimate the minimum gap between the two rails to be left. Okay, so that I hope the first part is clear to you. That gap is equal to the increase in the length due to temperature. Okay, so this much gap if we keep, then there will be no stress. Okay, but in the second question, it is given that the stress is 45 MPa now. Okay, since there is stress, so it means that we must have violated this. Like we haven't kept this much gap. Okay, suppose delta gap is required for no stress. So if it is given that 45 MPa stress is there, so we must have kept a gap lesser than delta. Is it clear? Okay, if the gap would be more than delta, then there will be no stress. Okay, is it clear? Is this thing clear ki why 45 MPa is generated? If it is not, then I'll explain again. Okay, see, the minimum gap for no stress is delta. If up till delta, if this rail will increase in length, there will be no stress. So but in the second part it's a different question. So in the second part it is given that what gap we have kept so such that the stress generated is 45 MPa. So we must have kept a gap which is lesser than delta. Okay, so what is the value of that gap it is asked. So this is the same problem like yielding of support, because in yielding of support also, there's a support. Okay, and if it yields by a amount, so up till that a amount no stress will generate, and after that a amount the stress will generate. Okay, so in this problem also the same case is there. Up till that a gap no stress will generate, and after that a gap exceeds, the stress will generate. So this is the same problem as the yielding of support problem. So we can simply use the yielding of support formula, which is L alpha delta t minus a e by l. Okay, so what you'll do, you'll remember all the formulas, but you should know where to apply that. Okay, so that was a thing that is important in this case. I hope it is clear. Or you can like read it again, or you can see the video again, or you can note it down, and if it is not clear, then I'll explain you in the next class also. Is it okay, Manna Bin?
Ma'am,
Yeah.
Okay, ma'am.
what about that? What if we are asked to solve for stress? What if we are asked to find the stress in that particular rail, which for which the extension is not actually given?
Extension by what do you mean by extension?
Delta.
Okay.
Delta, ma'am.
Okay, so that is given na. So if you are asked the value of stress, then you will be, then they would give you that whether there is a gap or not. If there is no gap between the rails, the stress will be simply E alpha delta T. Here you do not require the extension thing you are saying, right? You simply use the formula E alpha delta T. Suppose they gave you that find the stress in the bar with the gap between the two rails as let's say 1 mm. Let's say 1 mm. So this 1 mm will be your A value, that is the yield support value, and you will find the value of 6 stress by using this value. Everything is given na. L is given, alpha is given, delta T is given, A is given, E is given, and L is given, right? Lakshmi, is it clear? Did I get your
Yes, ma'am.
question right? You were asking now how will you find the value of stress. So stress, in case of no yield, the stress will be E alpha delta T. In case of yield means if there is some gap. Okay, if there is some gap between the support, between the two rails, that is the yielding in this case. So if the value of yield is also given, then you will use this formula. If no yield is there, then you will use this formula. I hope it is clear now.
Yes, ma'am. Okay, ma'am.
That's right. That's good that you are asking questions. Okay, now I'll move towards the next question. Okay, so next question, it is related to structural dynamics. Okay, just give me a minute. I'll share my screen. So this is the question which is I hope it is visible, right?
Yes, ma'am.
Okay, thanks. So this question is question number 7 of set 2 gate 2021. The same instructions are there. Please keep your pen, paper and calculator ready, and please write down the formula which I'll be using. Now the question is this.
Can I ask something?
Yeah.
In the previous question, the example you gave is 45 MPa.
Yeah.
And with the stress developed, decrease varies with the gap, ma'am.
Yes. Yes. Right. Like if the gap is more than, I hope this is, so if the gap is more than 4, what was the value we were getting? 4.32, I guess. If the gap is more than 4.32 mm, then no stress will generate, right? But if the gap will be less than lesser the gap, the more the stress. If there is no gap, the stress will be maximum. If the gap is like something like 1 mm, the stress will be lesser. If the gap is 2 mm, the stress will be even lesser, because then because why the stress is generating? The stress is generating because we are restraining the deformation. The more we restrain the deformation, the more stress will generate. Beyond 4.32 mm, we are not restraining anything. So after, like, beyond 4.32 mm, no stress is generating. But when the distance between the two rails is lesser than 4.32 mm, the stress will generate, and the lesser the gap, the more the stress, right? ठीक है? Is it okay?
Okay, ma'am.
Okay, ठीक है. So this problem is related to structural dynamics. Before starting the problem, I want to ask that how many of you have studied structural dynamics? I'm not going to ask you any formula. I just want to know, because in many colleges they don't teach structural dynamics, or they teach it in the last semester till the gate is over. Okay, just wanted to ask. maybe there's an option to raise the hand or something like that. Is there any option? If yes, not studied. Okay. Is there anyone who have studied? I'm asking you again because I'll not ask any question. I just wanted to know whether the colleges are teaching this subject or not presently. Okay. And if it is there, so in which semester? Like, is in the eighth semester till the gate is over, or after, like before gate is there? Seventh semester. Okay, so more or less after the gate only, because gate is over in the February mostly. Okay, so that's great. So because of this thing, that this and first thing is this subject is very like different from the conventional civil engineering subjects, and the another reason is this this subject is usually covered in the seventh or eighth semester. So after the gate basically. So what happens is student mostly completely leave this subject. Okay, so although this subject seems to be complicated and it is very wide also, so but in my opinion you should not completely leave this subject, because if you'll see the trend of gate, they usually covers very simple structural dynamics problem. So basically simple formula based. So at least you should remember that 5-10 formulas that you might get asked in for in gate. So usually one or two problem I think comes every time of structural dynamics, and very easy problems. So you should remember, at least if you are not covering the entire structural dynamics, you should remember at least 2 3 or maybe 5 6 formulas, so that you'll directly apply it and get the answer. Okay, so I'll start with the problem now. On this problem, a single story building model is shown in the figure. The rigid bar of mass m is supported by three massless elastic columns which are fixed against rotation. Okay. For each of the columns, the applied lateral force P and the corresponding moment m is also shown in the figure. The lateral deflection delta of the bar is given by delta equal to PL cube by 12 VI, where L is the effective length of the column, E is the Young's modulus of elasticity, I is the area moment of inertia of the column cross section with respect to the neutral axis. What we have to find for the lateral deflection profile of the columns as shown in this figure, we have to find the natural frequency of the system. So it might sound complicated, but for those who are like reading it the first time, but I'll try to explain it as easy way as I can. So basically in this question what happens is, this is a building model. So what happens in a building, there's a floor and there are columns, right? So the floor, which is very rigid, or which is very it has very high mass as compared to the columns. I hope you agree, right? The columns are can be considered as massless as compared to the floor weight. Okay, and they can be considered as more flexible as compared to the floor weight. So to simplify the problems in structural dynamics, what we do is we prepare this simplified model of a building. In this model, the floor is can be considered as a rigid bar, and columns are can be considered as massless. Massless means which do not have any mass as compared to the floor. So this is the building model, and it is given that we have applied a lateral force P. We have applied a lateral force P. So when we apply a lateral force P, what how will the this model deform? Let's see. Let's see if you agree with me. It will deform like this. All three columns will undergo some lateral deflection, right? I hope it is clear. And this bar will move a little bit in this direction. I hope it is clear, right? If we apply a lateral load P, so this is how this model should deform, right? So in the next figure, this same deflection pattern is shown in a zoomed out form. This is a same bar which is deflected horizontally, the value of horizontal deflection is given delta, which is given as PL cube by 12 VI. The moment is given M, and the lateral force is given as P. This is the question. I hope the question is clear. Now, what we are asked that find the natural frequency of the system. So why we require to find the natural frequency here? Let's see a case of a pendulum. So what happens is when you displace this pendulum from its like equilibrium position to here, so will it stay here or will it try to move towards its original position? Right? It will try to move towards this original position, but it will not be able to stay here also. That it will move a little bit here. So in this case, the pendulum will oscillate to and fro. Similar case with this building model also. Whenever earthquake happens or anything like that, any kind of lateral force occurs on a building, then what happens is it will laterally deflect, but after that force is over, it will try to get back to its original position, but it will not be able to stay there due to inertia, so there will be a to and fro motion. So whenever there is a to and fro or oscillatory motion, there will be some frequency of the system, right? So that frequency we are asked. Okay, so the question is not as complicated as I have explained it to you. You just have to put the formula and get the answer. But I'm just trying to explain the concept. Okay, I hope it is clear. Any confusion till this point? Any confusion? Is it clear, right? We have given a system, we have displaced it horizontally, and we need to find the natural frequency of the system. Why natural frequency? Because the system has become now an oscillatory is undergoing an oscillatory motion like a pendulum, so it should have some natural frequency. So in the formula of natural frequency from the physics 12th class physics also we have studied, omega is equals to under root of k by m. Okay, this is a simple formula we need to use, under root k by m. Although this question is seemingly complicated, but the simple formula we need to use is omega equal to under root of k by m. Here, what is k? K is the stiffness of the system. So if they would have been a single column, then k would be the stiffness of this particular single column. But now there are three columns, so omega will be k equivalent by m. So the entire problem revolves around how will we find k equivalent for this system. Okay, we simply need to use the formula omega equal to under root of k by m. If there would have been a single column, then K would be the stiffness of that column. But since there are three columns, so it has become a system now. So the value of natural frequency will be calculated as under root of K equivalent by M. So now we need to find the value of K equivalent. So if we will get the value of this K equivalent, we'll simply put it in the formula because mass is given as M only, and we will get the value of natural frequency. I hope the question is clear. Any confusion? Anybody? If it is clear, you can say yes, maybe, so that I can proceed.
Clear, ma'am.
Clear, right? Okay. So now the entire thing is how to find. Now the entire thing is how to find the K equivalent. Okay. So for this, I can simply give you the formula of K equivalent. You can put the value and get the answer. But I want to give you some concept so that some other problem which is related to gate, you can solve that also. Okay. So I'll explain the concept a little bit. Whenever the spring, so before going to springs, I'll tell you that rigid bar system which is given to us that we use in structural dynamics, but we can simplify this more by using a spring mass system. Don't get intimidated by these things. Okay, this is a very simple thing. I'm just replacing the column with a spring. Okay, so we can do that. This is K1, suppose this is K2, and this is K3. So this same system I've made it like this, so we can do that anytime. To simplify it more, I've just replaced the column with a spring. Okay, now when the spring are in series, whenever the spring are is in series, how will we find the value of equivalent stiffness, that is the K equivalent? So suppose this spring has stiffness of K1, this has a stiffness of K2. So how will we find a equivalent system which have stiffness of K equivalent? Suppose Fs is the, you don't have to remember the derivation, you just have to remember the formula. I'm just explaining so that those who are interested. Okay. So this is the formula of applied force Fs, and suppose this is the deflection here, right? So in this equivalent system also the force and deflection will be same, right? So in the series system, what happens is force in all the springs is same, but displacement is the sum in all the springs. Like this, if the applied force is Fs, it will be same Fs in K, this spring, second spring also and first spring also. But this displacement U will be the sum of two displacements. That is displacement of spring 1 and displacement of spring 2. And the most important thing you should remember is force is equals to K into U. I hope you know this. Force equal to stiffness into displacement. This formula is very, very important. Just remember this, okay? Now, we'll replace the value of U by F by K. I'm replacing it by F by K, F1 by K1 and F2 by K2 for this. And finally, for the equivalent stiffness, I'm getting the equivalent stiffness since Fs equal to F1 equal to F2. So these three will be cut down, and the value of K equivalent will be K1 K2 divided by K1 plus K2. The motive of explaining this is whenever the system or whenever the springs are in series, whenever the system is connected in series, then we'll calculate the equivalent stiffness as K1 K2 divided by K1 plus K2. You can note down this formula. Now, when this system is in parallel connection, so what happens when the system is in parallel connection? So how the parallel connection looks like? These are the springs in parallel. This is the force Fs applied, and this is the supposed displacement U. How will the equivalent system look like? Equivalent system will be a single spring. Equivalent system means the same system is replaced by a single spring. That is the K equivalent, and it is Fs and it is U. So in this case, like in the when the springs were connected in series, the force in all the springs were same. But here, the displacement in both the spring will be same, because when we will displace this system by U amount, this spring 1 and this spring 2 will displace by U amount only. So in springs in series, the force is same in springs, but displacement was different. When the springs are in parallel, then force is different and displacement is same. So this concept is only needed to derive the equation. Now Fs will be equal to F1 by F1 plus F2. We'll replace F equal to K into U. So Ke into U, K1 plus U1, K2 plus U2. U are same. So finally we get the value of Ke equal to K1 plus K2. So whenever the springs are connected in parallel connection, then Ke equal to K1 plus K2. If you don't want to remember the derivation, it is okay. It is not at all required. You just should remember whenever the springs are connected in series, the formula of equivalent stiffness is K1 K2 divided by K1 plus K2. And whenever the springs are connected in parallel connection, then K equivalent is K1 plus K2. The derivation is not at all important. Okay. Now, just tell me, the system which is given to us, is it a series connection or a parallel connection? You can write in the comments. I've just explained. That is great. That is great. So you understand, right? This is a parallel type of connection. So what formula for K equivalent we have to use? The formula we have to use it K equal to simple K1 plus K2. If it would have been a series connection, then it would be little much like computationally expensive. Like we have to solve it a little bit more, this formula. But now it is very easy. K equal to simply K1 by K1 plus K2. So for omega n, what do we require? We require K equivalent and M. K equivalent we simply know it is K1 plus K2, K1 plus K2 plus K3 and M. Now what is K1 and K2 and K3? ठीक है. K1, K2 and K3 will be same because they are this all these columns are similar in configuration. So we need to find what is that value of K1, K2 and K3. We'll simply add them up and we'll put it in the formula. Okay, so omega n equal to under root of k by m. That k by m thing we need to find it out. Now, just a normal introduction of how we get this value. So I'm writing the equation of motion here. This is, if you want, you can remember at least this equation, but it is not required for this question. I'm just telling you. So this omega is actually this is the natural frequency of the system. It is actually the coefficient of displacement. Here u is the displacement and u double dot is the acceleration. For those who are new to structural dynamics, you should not get worried about this. You just should remember this formula. I'm just telling you how this formula comes. So omega n is basically the coefficient of displacement. The coefficient of displacement is k. Coefficient means the thing which is near to it. Okay, so the coefficient of displacement is k and divided by the coefficient of acceleration, which is m. Here the unit of this thing omega n comes out to be is radian per second. Okay, for k should be in newton per meter and m should be in kg. This thing you should remember. For k to be in newton per meter and should be in kg, then we'll get the value of omega n as radian per second. So in this question, you are only asked what is the value of natural frequency. Maybe in the next year, they might ask you what is the value of this time period. Okay, the value of time period will be 2 pi by omega, and you will calculate omega n as the way I'm telling you, and you will simply put in the formula 2 pi by omega n. Okay, so omega n is under root k by m, where k should be in newton per meter and m should be in kg. I hope it is clear. Now we have to simply put in the formula, right? So I've told you F equal to K into U, right? Here F is P. Force is given as P. K is K equivalent. U means displacement, which is given as delta. So we need to find the value of K equivalent K1. For the first column I'm telling, okay, K1. For the first column, the stiffness is K1, force is P, U is delta, right? So what will be the value of K1 now? K1 will be P by delta. Delta is given to us. Delta is PL cube by 12 EI. Delta is given as PL cube by 12 EI. We'll simply put the value of delta here and we will get the stiffness of that column as 12 EI by L cube. Any confusion in this? We have to simply use this formula F equal to K into U. This formula is very important in any like dynamics also and in structural analysis as well. Like a stiffness method, you must have heard this formula. F equal to KU, where U is the displacement. So displacement is given to us as delta and force is given as P and stiffness of the first bar is K1. So simply K1 is P by delta. Any problem, any confusion in this thing? I hope it should be clear, right? So it is clear, right? So in K1 is known to us now. K1, K2 and K3 all are same. We just have to find the K equivalent as K1 plus K2 plus K3. We'll simply find it as it is coming out to be 36 EI by L cube. Now we'll put in the formula omega natural frequency equal to under root of K equivalent by M. K equivalent is 36 EI by L cube and M is M. Mass is given as M only. So 6 will come out, right? Under root of 36 is 6 will come out and under root of EI by ML cube and the unit will be radian per second. So our option will be, I guess, option number A. It was a very simple formula. I've told you in a lengthy way because I've explained the concept as well. But as soon as you see, you don't have to worry about the entire question, as you just see what is given to you. As soon as you see the natural frequency is asked, that should be clicked like omega n equal to under root of ke by m. Now, if it is only a single bar, you don't have to find k equivalent at all. You just use the value of k and in the formula. But if k equivalent is like if it is a system of springs or system of columns, then you will find the value of k equivalent. First, you should see whether the system is in series or in parallel. If the system is in series, then you'll use the formula of k equivalent as this one. If the system is in parallel, you'll use the formula as k1 plus k2, and simply you'll put the value in this question. Okay, so maybe in the next year they can ask you what is the value of time period. Okay, so time period also you'll calculate the value of omega n, and you will put it in the simply in the formula 2 pi by omega n. Okay, so these are very simple questions they ask, but they look like complicated, so people can like simply leave them. So you should not leave them. At least remember these formulas of k equivalent, and the formula of that natural frequency, and the formula of time period. Maybe these 2 3 formulas at least you should remember and practice. Okay, so now I'll move towards our practice problem. Very easy problem based on the same formula. Okay, it is given that there is a water tank. There's an overhead water tank. You must have seen there, and like in your locality also. There's an overhead water tank which is supported by a column. So this is a model for this. The uh, dimensions of the overhead tank is given. The dimensions of column is given. Okay, what we have to find out, just focus on what you need to find out, then you will formulate the formula and things accordingly. You need to find out the natural frequency for horizontal vibration and the natural frequency for vertical vibration. They have made the problem even easier. Instead of giving delta, they have given the value of k. So you know the formula of omega n, right? Omega n is under root of k by m. K is given. Okay, so they have asked two things: natural frequency for horizontal vibration and natural frequency for vertical vibration. The natural frequency for horizontal vibration will be under root of k horizontal by m simply, and natural frequency for vertical vibration will be k vertical by m. Just put in the formula. K horizontal is given. K horizontal is given as 3ei by L cube. Even in this case, you don't have to find a k equivalent also, but just you need to solve. And k vertical is given as ea by L. The only thing you should see is that how to find the mass. Here the mass is not directly given. Okay, so here that what is given, unit weight of water is given, which is 1000 kg per meter cube, and volume of overhead tank you can find 6 into 6 into 6 will be the volume of overhead tank. You can find out the mass by multiplying this volume with 1000, so you'll get the mass in kg. Okay, I'll explain it. You want to try? Maybe there's no time, so I'll explain it quickly. Okay, so mass of the tank filled with water will be 6 into 6 into 6. That is the volume of the tank multiplied by the unit weight of water. So this will come out in kg. You should solve it yourself. Okay. Just modulus of elasticity. Modulus of elasticity is given 20 GPa. So I'll keep it in 20 GPa is given to 10 to the power 9 Newton per mm square. Okay. Okay. I is the moment of inertia. Moment of inertia, this is given na ki it is a overhead tank of square so it is given that it's a square column. So for square, the value of I is bd cube by 12. Everything I'm keeping in meter, should also be converted to meter now. Yeah, so b is given as zero point 0.6, d is 0.6 bd cube by 12, and Similarly, you'll find the value of kh. Now put all the values and you will get the value of kh. Okay. Similarly, for vertical vibration, you will find the value of ke as e a by l. Everything you know. Value of e is known. Value of a you can calculate. The length of column is given as 10 meter. You can find out the natural frequency for vertical vibration as kV by m. So just a matter of calculation. Just you need to keep in mind that when you are putting this formula as k by m, then k should be in Newton per meter and mass should be in kg. Just to like note this thing, I've given this question to you. Okay, so maybe in the next year they won't give you this concept related problem. They'll give you this the problem in which more calculation is required. Okay, so formula is very simple. See, in every type of problem the formula is simple. Just you should not get intimidated by this dynamics thing. You just remember, at least remember few simple formulas, then you'll be okay. At least you should not leave the entire subject. This is the motive. I hope you'll solve it at your home. You just need to apply this formula. And if you will come in the next session, then we'll discuss the answer also. Okay, so is it fine for today? Any questions? I hope it is clear, right?
Ma'am,
Yes.
I have one small doubt, ma'am.
Yes.
In first gate question that discussed in that in the temperature stresses gate question, ma'am.
Okay, got it. This one.
Not in practice
Acha,
problem.
gate problem. Yes.
Yes, ma'am. While solving it,
Hmm.
change in hi, change in length of hi is equal to 0.
Mm-hmm.
The P is acting on hi, no, ma'am.
P is acting in the joint. In the
Ah,
joint, yeah, in the joint which is connecting, it's acting at I location. So H and both HI and IJ are connected. So P is acting in the joint.
okay, ma'am. In that I location means we have to take 2 AE or AE, ma'am. Point equating strain is equal to 0.
I got your point. Actually, in this question, it is given that force in HI should be 0. Okay, force in HI is 0 means deformation is 0 in HI. Okay, deformation is in HI is 0. This implies that deformation, what what do you mean by deformation in HI is 0? Deformation in HI is 0 only if IJ has not been deformed. Okay, so when this IJ was increasing in temperature, this load P is balancing that thing so that HI is not deforming. So we are balancing the force in IJ so that IJ will not deform. If IJ will not deform, then HI will not deform automatically.
Okay, ma'am.
We are not focusing on HI because HI, no force is coming in HI. No force is coming in HI means everything which is happening in IJ only. HI is not getting affected at all. So IJ was, when temperature was increased, IJ was trying to expand, but at the same time that P load is applied, so it has stopped IJ to move. So the forces are balanced in IJ. If forces are balanced in IJ, HI will automatically not deformed. So this can be a confusing point. Some might like use that AE of that HI, but HI is not getting any force at all. Whatever that is happening in IJ. That was a good question anyway.
Thank you, ma'am. Understood, ma'am.
Okay. Okay, so I hope it is clear for today. Okay, so the next class, maybe I'll update what I'll be covering. I'll be covering gate questions only, but you should just take some note down the formulas which I'll be using, and then the similar practice problem will be solving every week. Okay. Okay, then thank you so much. And I think somebody has asked some question. Ma'am, will they be recording of this session? Okay. Yeah, they'll be recording of this session, and they'll be recording of proper gate videos will be there, like in the portal. But I don't know when they'll upload them. We will send the videos to NPTL team, and then we'll see how, when they'll upload it. This recording maybe I'll upload in my YouTube channel. Maybe I'll see that. I'll try to upload it. Ma'am, where can I find the full study plan? full study plan, I don't understand what do you mean by full study. If you want to like you should, first of all, you should download the syllabus, and if you want to follow the NPTEL, then you have all the videos there. So they have done the proper syllabus mapping, and they are also providing, even maybe I don't know if it is live or not, they'll be all they also will provide the what do you say, test, practice test also, and they are providing the gate live mentoring session also, and they are providing the all the solution of all the gate problems also. I haven't been able to get the previous recording. Can you okay, I haven't made the channel yet, maybe I'll made it this week and upload the recordings there. Okay, so okay. Any questions? Is it okay? Should I leave now? Okay, thank you so much. Thank you everyone for listening. And please practice these questions, and follow the similar. Whenever you practice a question gate problem, try to see how that problem could be modified a bit. So because never ever they'll give you a similar problem, they'll somehow modify it and make it more complicated. So try to grasp the concept, because in these problems you have seen that formula is very simple, but by simply remembering the formula, that will not work. So you have to know the formula, and you should know how to apply it, and that you'll know only after a lot of practice. Okay. Okay, then thank you so much. Thank you. Bye.